In this video I will be solving question number 5070 May June 23 question paper 42. Let's start. Question number 1. A student investigates the rusting of iron. Figure 1.1 shows the apparatus the student uses. So these are the three apparatus used, and you know that the condition of rusting is moist air, or air and water. So in this first test tube, iron nail is dipped in the water, and the tube is kept open. So it means air enter in the test tube and nail will be rusted. And in second test tube, tube is airtight, and there is dry air, there is no water, so it means water is absent, so that's why no rusting. And in the experiment C, you know that oil is layer of oil on the water, and layer of oil prevent the air to enter in the test tube, so iron nail will not rusted. So in experiment A, in test tube A, there is a rusting. Name apparatus X. This is test tube. State why a stopper is used in experiment B to prevent the water vapor to enter in the to prevent the air to prevent the water vapor. This is correct. To prevent the water vapor to enter in the experiment B. State why the water in experiment C is boiled before use. Water is boiled before use because to eliminate oxygen or to remove oxygen. State why a layer of oil is used in experiment C so that oxygen does not enter in the test tube. The experiment are left for 1 week. Predict in which experiment the nail will have rusted. In experiment A, the nail will have rusted. Explain your answer as oxygen and water. Both conditions are present in experiment A, so that there is rusting of iron takes place. Question number 2. Ammonia. Aqueous ammonia is solution of ammonia gas. A student titrates 2 sample of aqueous ammonia A and B with 0.500 mole per dm cube hydrochloric acid. The student does 4 titrations, 2 with A and 2 with B. Step 1. Drains and fills a burette with 0.50 mole per dm cube hydrochloric acid. Step 2 uses a volumetric pipette to add 25 centimeter cube of A solution A to a conical flask. Step 3. Add 5 drops of methyl orange indicator to the conical flask. Step 4. Place the conical flask on the white tile. Step 5. Add 0.500 mole per dm cube hydrochloric acid from the burette while swirling the contents of the flask, adding drop by drop near the end point until the solution just changes the color. You know that this is the titration procedure. This is the titration method. And step 6 empties the conical flask and rinses it with distilled water. Step 7 repeats steps 2 to 6. Step 8 repeats step 2 to 7 using aqueous ammonia B instead of aqueous ammonia A with different concentration. Okay, this is the figure shows the burette reading for the 2 titration with A, titration 1 and titration 2. So this is the initial burette and this is the final burette. This is initial burette, this is initial burette, and this is final burette. Initial burette and final, these are the 2 titrations. So now this is very important to note down. This is very easy question to note down the volume from the burettes and fill this table. Record the burette readings in table 2.1. Complete table 2.1 with the volume used in each titration. This is the final burette of titration 1. Final burette reading is 15.2. So this is 15.2. Initial is 0. This is initial burette reading 0.0, and when we subtract we get 15.2 volume used in titration 1. Titration 2 initial is 30.2. This is the 30.2 is the initial reading, final reading, and 15.2 is the initial reading. Though the volume used for this titration is 15 centimeter cube. So how to get mean volume of this by adding these two volume 15.2 and 15. We get the average volume used divided by 2. Now fig B part 2.2 shows the burette readings for one of the titration with B. This is final burette reading, this is initial. Record the burette readings for titration 4 in table 2.2. Complete table 2.2 with the volume used in each titration. So some values are given and some values you have to find out from the titration, from this titration 4. Initial final reading of titration 4 is 35.5. This is 35.5, and initial reading is 0.6. This is from 0 to 6, 0.6. And when we subtract, by subtracting initial volume from the final volume, that is equal to 34.9, and this is 34.7. Explain why the student uses a white tile in these titrations so that change can be visible. Okay, so color change can be visible when we use white tiles under the conical flask. Calculate the mean volume of 0.500 mole per dm cube hydrochloric acid needed to neutralize 25 centimeter cube of A and B. Mean volume of acid needed for solution A is 15.1, and mean volume needed of acid needed for solution B is 34.8 centimeter cube, which we get from here. This is mean volume is 34 point, mean volume of these two reading is 34.8. By using these two values, 34.7 plus 34.9 divided by 2, that is 34.8. And solution A we use like this, 15.2 plus 15 divided by 2, we get the average volume. So this is the mean volume or average volume of acid needed for solution A, and this is mean volume of acid for the solution B. Now E part, the equation for the reaction between hydrochloric acid and aqueous ammonia is shown. Use the mean volume of acid needed to neutralize 25 centimeter cube of A in D to calculate the concentration of ammonia in A. Give your answers to an appropriate number of significant figures. So first we have to calculate moles of HCl and mole of HCl by using concentration into volume in centimeter cube divided by 1000. We have volume concentration is 0.500 mole per dm cube and volume is 15.1 divided by 1000. So we get 7.55 into 10 raised to power minus 3. By using the mole ratio, we get the mole of ammonia. Mole is 1:1, so 7.55 into 10 raised to minus 3 is the mole of HCl. So in this way we get mole of ammonia, that is 7.55. Now we have to we can find out the concentration of ammonia by using mole over volume in centimeter cube multiplied by 1000. So this is the concentration of ammonia, 0.302 mole per dm cube. Calculate the volume of ammonia gas measured at room temperature and pressure dissolved in 25 centimeter cube of A. So the volume of 1 mole of gas is, we know, that is equal to 24 dm cube. Volume of so this is mole per dm cube, so we are using this mole for ammonia. and it is multiplied with 24 decimeter cube because volume of gas is equal to mole into 24 dm3 molar gas volume. So the answer is volume is 0.812 dm cube. Choose your answer D and F to calculate the volume of ammonia gas measured at room temperature. uh, Measured at room temperature, dissolved in 25 centimeter cube of solution B. This is solution B. We know that 1000 centimeter cube is equal to 0.55. So what would be the mole of HCl in 34.8? So this is 0.0174. So HCl ratio Na3 1:1 and with 0.0174 ratio X. So now we can find out mole of ammonia gas in solution B. Mole ratio volume 1 mole is equal to 24 dm cube. So what would be the volume if mole is 0.0174 ratio X? So by using cross multiply, we choose by calculating, we have 0.4176 volume of ammonia in solution B. So this is we need to write down in two significant figure. So this is 0.176. So we should write down 0.42 decimeter cube volume. The student rinses the burette with 0.500 mole per dm cube hydrochloric acid, and immediately before it is filled, explain why the student should not rinse the burette with distilled water immediately before it is filled with 0.500 mole per dm cube hydrochloric acid, as some water left in the burette, so which make acid dilute. So that's why student should not rinse the burette with distilled water. Suggest why universal indicator is not suitable for use in these titrations. Color change could not be visible with the universal indicator, so that's why we are not using universal indicator in these titrations. Question number 3. A student investigates solution W and solid X. Solution W is green in color and contain iron 2 ions. Describe how W can be shown to contain iron 2 ion. Add sodium hydroxide. This is a cation test. You can use the if you don't know, if you the test of cations, so you can see the cations test over here. So the write down the test of cations so check the test of cation from the table and write down over here. So describe how W can show that it contains Fe2 ion. Add sodium hydroxide till the change can be seen, and then excess. Green precipitate insoluble in excess. Excess W is added to acidified potassium manganate 7. Describe the color change seen. So color change is so this is the reaction manganate iron 2 to form iron 3 to manganate. So this is iron solution. So the solution, the color change will be purple to yellow, and solution of iron 3 is yellow in color. Okay. Describe the observation made when a few drops of aqueous ammonia and then an aqueous ammonia are added in the mixture from 2. Few drops red brown precipitate of iron 3 and in excess ammonia precipitate remain insoluble with excess of ammonia. Solid X is shining gray metal. The test the student does on X are shown in table 3.1. Some of the observations for these tests are shown, and add excess of dilute acid to X in a test tube. The gas produced is tested. Solid disappears, solution remains colorless and becomes warmer. Okay. Add dilute nitric acid, then add aqueous silver nitrate to some of the solution from test 1. Solution remains colorless, so it means If this is the test of halide ions, halide ions mean chloride ion, bromide ion, and iodide ion. So it means if solution remains colorless, it means all halide ions are absent. Add dilute nitric acid, then add aqueous barium nitrate to some of the solution from test 1. So if white precipitates are formed, it means sulfate ions are present. So this is the chemical reaction of this test. Predict the identity of the gas predicted in test 1. So X is a gray metal, so when it solution remains and becomes warmer. So when gas is formed, this is exothermic reaction, so that's why it means hydrogen gas is there. And the test of hydrogen gas is bring lighted supplant in the gas jar. Gas produces pops in flame with lighted supplant. With lighted with lighted supplant. The observation for test 1 are incomplete. State one other observation that the student makes for the test 1, that the effervescence of the gas. State the conditions you can make from test 2. No halide ions are present because color solution remains colorless. It means when no precipitates are formed, so it means halide ions are absent. State the conditions, conclusions you can make from test 3. Sulfate ions are present because white precipitates are formed. This is the test of sulfate ions. So if white precipitates when formed, it means sulfate ions are present. Identify the acid used in test 1. Sulfuric acid. Suggest the identity of metal X. It can be zinc or magnesium. Magnesium reaction is this: when react with sulfuric acid to form magnesium sulfate and hydrogen gas. And this is the reaction for sulfate ion. This is reaction for sulfate ion, test of sulfate ion. Baking soda is used to make bread rise. When baking soda is heated, it decomposes and carbon dioxide gas is released. Baking soda also decomposes gradually when it is stored. The longer the baking soda is stored, the less carbon dioxide it releases when it is heated. Plan an investigation to show which of the two different samples of baking soda has been stored for longer. Your plan should include the use of common laboratory apparatus and the two samples of baking soda. No other chemical should be used. Your plan should include the apparatus needed, the method to use, the measurement to take, the variable to control. How to use the results to determine which sample has been stored for longer time. So he all informations are there. This baking soda which is stored for longer time produces less carbon dioxide, and baking soda which is uh, has been stored for longer. To show which of these, so baking soda is stored and stored the less carbon dioxide it releases when it is heated. The longer the carbon baking soda, so it means shorter the time, more carbon dioxide is releases when it is heated. So you may draw a diagram to help your to answer the question. So the apparatus should be electronic balance, Bunsen burner, test tube, gas range. And you know the variables are, there are two types of variables that you should know the variables in the, if it is written in the experiment. Dependent variable which what we measure, and independent what we change, जिसको हम change कर सकते हैं, तो that is the independent variable, and dependent what we measure. Method: measure the same mass of baking soda for both the samples. Heat the samples by using Bunsen burner. Measure the volume of gas, carbon dioxide collected in the gas range. Control variable: heat both the sample to the same temperature. Temperature should be same, and sample mass should be same. Same amount of intensity, same surface area of baking soda is used in both the sample. The conclusion will be sample which produces more carbon dioxide gas is stored for shorter time. produce more carbon dioxide, gas is stored for shorter time. So this is the apparatus which we can use for this experiment. Stopwatch, this is the thermometer, test tube, Bunsen burner, spirit lamp, and this is gas syringe and gas is collected. So this is all about this paper. Hope you will be understand. If you like this video, please share this video and subscribe this. Thank you.